My name is John Marlin, and I'm a program manager on the high availability and storage team. I own the failover clustering component, and this video series details many of the new features with Windows Server 2019 failover clustering. As a recap, in part 4 we talked about the true two-node hyperconverged, nested mirror, and nested mirror accelerated parity for our resiliency levels for it. Talked about the new file share witness capability, the ability to use USB drives off a router in edge scenarios. Talked about the new split brain detection that we have. We detect a partition, we reform the cluster to help alleviate data loss possibilities. And we talked about some of the security stuff, no more NTLM dependencies. In part 5, we're going to talk about some of the new scale-out file server enhancements, what we did with cluster shared volumes, marginal disk detection, which is new for 2019, and some of the new features with cluster aware updating. First thing we want to talk about is scale-out file servers and how we made them better. The first option we did was SMB connections moving on connect. In previous versions, when a client connects to a scale-out file server, if that user is connecting to a CSV drive that is owned by another node, it's connected, data starts flowing, we see, hey, we need to move this over to the node owner of the CSV so that it can be all local access. It then moves it out, so it'll pause some of the I/O from the client, move the connection over, and then resume it. In 2019, what we did was the moment we connect, we will see, okay, who are you trying to access? If the CSV is owned by another node, it will then move it there before any data access is there. So there's no more delays in connections. Once data is started, it moves it right then, right off the bat. We added SMB loopback support. This was specifically done for cluster sets. With cluster sets, the paths to VHD files, or the VHDX files, whichever you may be using, is a network path. If the virtual machine and the VHD are both on the same node, still allows that network connection to be there, but uses it as local. So it creates a loopback, which we did not support before. Identity tunneling is something that we had done. Again, this is more along the lines of some of the ACLs that we do. Again, as I mentioned in a previous video, the ACLs for a VHD, or VHDX, on a local access virtual machine versus remote access of the virtual machine are two different sets of ACLs. With 2019, it's the same ACL. We're actually taking the identity and tunneling it across. So it makes it to where we do not have to have multiple ACLs now. The infrastructure scale-out file server role is new. This was something that was created for cluster sets. It can be used for other things as well, but it was originally done specifically for cluster sets. Same premise as a scale-out file server in that it's a distinguished network name, but as soon as you create it, it automatically creates the shares for you based off the CSV volume names. The other caveat to it is there can only be one infrastructure scale-out file server role in a cluster versus a traditional scale-out file server where there could be multiples. You can only have one infrastructure scale-out file server in a cluster with 2019. For CSV, cluster shared volumes, CSV cache continues to be enabled. We actually enabled it in 2016, but in 2016 we did not give a cache size. One of the things that we kept getting asked is, what's a good size to start with? This is my workload. This is what I want to, what should I set it for? So in 2019, we're now allocating 1 gig memory as a default. Now, this 1 gig memory may or may not be enough or too much for your particular workloads that you have. It's all going to be dependent on that workload. We have included, and it's always been there, specific counters for the CSV cache. Once you load up the cluster, do it as CSV, put your workloads on it, load up your performance monitor counters for CSV cache, do some testing, and then just kind of monitor it. Do you need to increase it? Could you decrease it? It's all up to you. The 1 gig is not a set limit. It could be raised, could be lowered. Like I said, it all depends on your workload. From a security standpoint, there's a new property, security level to storage. We can now encrypt CSV traffic. So now we have increased security for CSV so that, network sniffers can't just get over the network and see what's going on, see what's being there. We have encrypted it now, and it uses it based off a lot of the certificates and such that we use. One caveat to it is if you encrypt a network, RDMA is no longer going to be used. So there are pros and cons to securing or encrypting the traffic. It's not going to disable RDMA, it just is that RDMA will not be used. So remember that and consider that if you want to encrypt the traffic. Marginal disks. Windows has always done a pretty good job when everything is all and functioning well with drives. It's also reacted pretty well whenever drives simply go bad and die. What we haven't had a real story on or reacted well to is marginal disks. So a disk that's starting to go bad but not really bad yet, but it's still functioning. So what we did is we hardened the stack to detect drives reaching end of life, or they're just simply misbehaving. More bad spots on it, spots going bad. What we're doing now is we're actually sending alerts through the cluster health service so that you can be aware of possible issues with a drive beforehand. Some of the things we are looking at is high latency and disk errors. If there are those, we will flag the drive as abnormal latency. Using Windows Admin Center, the option to retire the drive is one click away. When we do flag the drive, we will stop writing to it. We will start moving things off of it so that that drive is no longer used. So as an example, here's an alert that would pop up that you would see inside of Windows Admin Center. You can see here's my drive. It has 176 bad blocks that we've detected, and it's exceeded a safe threshold of 25 in a period of 7 days. The thresholds are options that you can modify. So, gives you the time of when the alert happened, 25 minutes ago here, and then gives a suggested action of replacing the drive. If you click on go to drive, it will actually pull it up inside of WAC to the drives and the inventory and give you the option to retire it so that it can be replaced. For cluster aware updating and Windows Update, we've made some enhancements. And a lot of this is with Storage Spaces Direct in mind. First, we will check to see if storage jobs are making progress and wait before we try and skip it to move on. One of the things in the past is you run cluster aware updating on Storage Spaces Direct. If there are any storage jobs going on, we just patch the node and reboot it. If a storage job was in the process of going, then it gets interrupted on the reboot, which is not always a good thing. Now we will detect if storage jobs are running, and then as long as they are making progress, we will wait before we do anything. Something new here, which has always been an ask, is to test what's going to happen. So we can do a test force and drain even if no updates are available. So it will basically react exactly like that it would do if there was an update. So you can do this even if there are no updates available. A lot of times, there is no test. The only test is an actual update being available. So you can test it out beforehand to see if it reacts exactly like you want it to. This is generally done for troubleshooting and testing. The PowerShell commandlet save CAU debug trace collects a lot of the cluster aware updating logs. It will now collect the Windows Update logs, which it did not do before. With a lot of clusters and S2D clusters, especially ones running virtual machines, there is a lot of memory. So it takes a while for a reboot to go through the memory count. We have now extended the wait times to be longer for those machines that need longer boot times. So we extend it out before we move on. And then one of the biggest things, and this especially relates to S2D, you reboot an S2D node, there's some storage jobs that are going to run in the background once it comes back up. Not all updates require a reboot. If you have an update that does not require a reboot, we will install the update and then move on. We will no longer have a reboot every time there's an update is there, whether it requires one or not. If it doesn't, install the update, move on. So to wrap things up, we talked about some of the new scale-out file server enhancements. Move the SMB on connect instead of after connection and data has already started flowing. We talked about some of the new cluster shared volume with the CSV cache having a memory range now, as well as the ability to encrypt the traffic, marginal disk detection for misbehaving disks, and then some of the new stuff for cluster aware updating. Biggest things being, are there storage jobs running? If there are, let's wait. Testing to see what would happen, even though there are no updates available. And then if an update does not require a reboot, do not reboot the node. In part 6, we're going to talk about a couple of the new cluster network name enhancements that we've done. Some of the enhancements we've done for clusters in Azure, and then domain migrations. I want to thank you for watching this video.